Now that you understand Stackdriver from a high-level perspective, let's look at Stackdriver monitoring. Monitoring is important to Google because it is at the base of site reliability engineering, or SRE. SRE is a discipline that applies aspects of software engineering to operations, whose goals are to create ultra-scalable and highly reliable software systems. This discipline has enabled Google to build, deploy, monitor, and maintain some of the largest software systems in the world. If you want to learn more about SRE, I recommend exploring the free book written by members of Google's SRE team. It is in the link section of this video. Stackdriver dynamically configures monitoring after resources are deployed and has intelligent defaults that allow you to easily create charts for basic monitoring activities. This allows you to monitor your platform, system, and application metrics by ingesting data such as metrics, events, and metadata. You can then generate insights from this data through dashboards, charts, and alerts. For example, you can configure and measure uptime and health checks that send alerts via email. A workspace is the root entity that holds monitoring and configuration information in Stackdriver monitoring. Each workspace can have between 1 and 100 monitored projects, including one or more GCP projects and any number of AWS accounts. You can have as many workspaces as you want, but GCP projects and AWS accounts can't be monitored by more than one workspace. A workspace contains the custom dashboards, alerting policies, uptime checks, notification channels, and group definitions that you use with your monitored projects. A workspace can access metric data from its monitored projects, but the metric data and log entries remain in the individual projects. The first monitored GCP project in a workspace is called the hosting project, and it must be specified when you create the workspace. The name of that project becomes the name of your workspace. To access an AWS account, you must configure a project in GCP to hold the AWS connector. Because workspaces can monitor all of your GCP projects in a single place, a workspace is a single pane of glass through which you can view resources from multiple GCP projects and AWS accounts. All Stackdriver users who have access to that workspace have access to all data by default. This means that a Stackdriver role assigned to one person on one project applies equally to all projects monitored by that workspace. In order to give people different roles per project and to control visibility to data, consider placing the monitoring of those projects in separate workspaces. Stackdriver monitoring allows you to create custom dashboards that contain charts of the metrics that you want to monitor. For example, you can create charts that display your instance's CPU utilization, the packets or bytes sent and received by those instances, and the packets or bytes dropped by the firewall of those instances. In other words, charts provide visibility into the utilization and network traffic of your VM instances, as shown on this slide. These charts can be customized with filters to remove noise, groups to reduce the number of time series, and aggregates to group multiple time series together. For a full list of supported metrics, see documentation linked for this video. Now, although charts are extremely useful, they can only provide insight when someone is looking at them. But what if your server goes down in the middle of the night or over the weekend? Do you expect someone to always look at dashboards to determine whether your servers are available or have enough capacity or bandwidth? If not, you want to create alerting policies that notify you when specific conditions are met. For example, as shown on this slide, you can create an alerting policy when the network egress of your VM instance goes above a certain threshold for a specific time frame. When this condition is met, you or someone else can be automatically notified through email, SMS, or other channels in order to troubleshoot this issue. You can also create an alerting policy that monitors your Stackdriver usage and alerts you when you approach the threshold for billing. For more information about this, see the link section of this video. Here's an example of what creating an alerting policy looks like. On the left, you can see an HTTP check condition on the Summer01 instance. This will send an email that is customized with the content of the documentation section on the right. Let's discuss some best practices when creating alerts. I recommend alerting on symptoms and not necessarily causes. For example, you want to monitor failing queries of a database and then identify whether the database is down. Next, make sure that you're using multiple notification channels, like email and SMS. This helps avoid a single point of failure in your alerting strategy. I also recommend customizing your alerts to the audience's need by describing what actions need to be taken or what resources need to be examined. Finally, avoid noise, because this will cause alerts to be dismissed over time. Specifically, adjust monitoring alerts so that they are actionable, and don't just set up alerts on everything possible. Uptime checks can be configured to test the availability of your public services from locations around the world, as you can see on this slide. The type of uptime check can be set to HTTP, HTTPS, or TCP. The resource to be checked can be an App Engine application, a Compute Engine instance, a URL of a host, or an AWS instance or load balancer. For each uptime check, you can create an alerting policy and view the latency of each global location. Here is an example of an HTTP uptime check. The resource is checked every minute with a 10-second timeout. Uptime checks that do not get a response within this timeout period are considered failures. So far, there is a 100% uptime with no outages. Stackdriver monitoring can access some metrics without the monitoring agent, including CPU utilization, some disk traffic metrics, network traffic, and uptime information. However, to access additional system resources and application services, you should install the monitoring agent. The monitoring agent is supported for Compute Engine and EC2 instances. The monitoring agent can be installed with these two simple commands, which you could include in your startup script. This assumes that you have a VM instance running Linux that is being monitored by a workspace, and that your instance has the proper credentials for the agent. If the standard metrics provided by Stackdriver monitoring do not fit your needs, you can create custom metrics. For example, imagine a game server that has a capacity of 50 users. What metric indicator might you use to trigger scaling events? From an infrastructure perspective, you might consider using CPU load or perhaps network traffic load as values that are somewhat correlated with the number of users. But with a custom metric, you could actually pass the current number of users directly from your application into Stackdriver. To get started with creating custom metrics, see the links section of this video.